Welcome back. This is lesson 1.2 about the properties, and our objectives are going to be able to define and recognize properties of addition and multiplication. Let's get started. We're going to start with the commutative property. We'll do definition and an example. So the commutative property just says that the order doesn't matter, and this is for multiplication and for addition. So order does not matter. I like to call this the flip-flop rule, some flip-flops. And also a commute would be like moving or driving, like your commute to work or school. But the most easy one to remember is the flip-flop rule, because you can flip-flop the order and the answer is the same. For example, 1 plus 7 equals 7 plus 1. Or 2 times 3 equals 3 times 2. Remember, you should be taking some notes on these so you can remember them. You're going to have to be able to use these properties and identify them when we do our practice. So this is the flip-flop rule, the commutative property. Also, a small reminder that this dot here in the middle, that means multiply. So in algebra, we've graduated from the x as multiply. We are not going to use that anymore because it could get confused with our most popular variable, x. So multiply, we're going to use this dot there. We're not going to use that anymore. We've graduated from it. Next, we have the associative property, and I like to call this the my buddy rule. There your buddy is. And an associate is someone that you work with or that you know, that you associate with. So it's the associative property. And this property says that grouping does not matter. So grouping or associating, grouping does not matter. And the way that we group in math a lot of times is by using parentheses. So in an example, be 1 plus 2 plus 3 is the same as 1 plus 2 plus 3. You're going to get the same answer either way. And then also this does go for multiplication too, so we can just use the same numbers here. And when a number is right outside of a parenthesis right here with no space or anything in between, that does mean to multiply. So here the grouping does not matter. And if you want to pause and work these out, you'll see that you're going to get the same answers on both sides here. This is for multiplication and addition. Next we have the inverse property, and that is just using opposites to quote unquote cancel a value. We call it canceling a lot of times. Now these are a little different for multiplication and for addition. So first we will start with addition. So for example, if we do 3 plus negative 3, we're going to get to 0. That's how we kind of get rid of that 3, so to speak, or cancel it. For multiplication, this one is a little bit different. We might not know this as well. To cancel for multiplication, you're going to multiply by 1 over the number that you want to get rid of, and that will give you 1. The reason that this works, now, this is all you have to know about the property, what I just did here. But I want to show you why this works so you know. Any whole number written as a fraction, you put it over 1. So 3 is the same as 3 divided by 1, or 3 over 1. And when we flip it, the top and the bottom, that is going to give us, we multiply straight across. 3 times 1 is 3, over 1 times 3, which is 3. 3 divided by 3 is 1, and that is why it works. So all you really have to know is this. But here, I will always try to tell you why the things that we do work. We can move on now to the zero product property. This one is pretty straightforward. Multiply by 0, you always get 0. This is just for multiplication. Product is the answer to a multiplication problem. So the definition here, it's just anything by 0 times 0 equals 0. So multiply by 0, it's always 0. We knew that. Now we know what to call it. We can have an example. If I have $17,000 0 times, I've got $0. We can make it dollars. Moving right on here. Now we have the distributive property. And the distributive property tells us how to multiply something by a quantity or something else in parentheses. So here, this is when we multiply a value I call this the rainbow rule. So there's my rainbow. So an example here, we have 2 times x plus 7. We're going to take and make rainbows and multiply this 2 by both values on the inside here. So we've got 2 times x, which equals 2x, plus 2 times 7, which equals 14. So these two equal each other. We can also do this with a variable first. We can multiply a variable by what's on the inside here. So we're going to use our rainbow rule and multiply the outside by each one on the inside. That's important. We have to hit everything on the inside no matter how many there are. So here we have AB minus 3A. And normally we put the variable on the back there instead of saying A3. We usually put it at the back, so it would be 3A. This is a distributive property. We'll use this one a lot. This is a very important property. Next, we have the reflexive property. I have a little mirror down there because it kind of sounds like reflection. And the reason that is maybe helpful is because the definition is that a value always equals itself. We know this. You're probably thinking, Ms. Z, why do I have to know these? These are some of these are common sense. Why do they have to have names? Because in a few lessons, you're going to have to be able to use these to say why you are following the steps that you are. So just because you know something, you have to be able to know what it's called in order to be able to use it for proofs and things. So we know that values equal themselves. I don't need to say much more about it. Like 16 equals 16. X equals X, right? It equals itself. It's like a mirror or a reflection. Next, we have the symmetric property, and on the bottom there, I've got some pictures of symmetry, so it's the same thing on both sides. And this just kind of tells us that we can take and switch the sides. So if A equals B, then B equals A. Again, we know this. We're used to this. So if X equals 3, then 3 also equals X. We can flip them around. That's the symmetric property. Last property that I'm going to go over with you is the transitive property. And this one says that if A equals B and A equals C, then B equals C. Okay, so that could sound like a lot. It's a little bit hard to think about, at least for me, in terms of letters. I call this the fake friend property. And here they are. Here are our fake friends. The reason I call it this is because let's think of it this way. So we'll say that this is me. I've got a friend, Brad. My name's Alexa, so I've got a friend, Brad, and I've got a friend, Courtney. And I think that they would get along. So I introduce them. Then they start hanging out without me. That is what this property is about. So if I say that 4 plus 3 equals 7, and 7 equals the square root of 49, then 4 plus 3 equals the square root of 49. We're getting rid of the middle. We're removing what they share. So there are 3 elements here, and if 1 equals 2 of them, so if A equals B and A equals C, then they equal each other, and that's my fake friend property. Think of someone hanging out without you after you've introduced them. That is it for the properties. These are all the properties that you are going to have to be able to use and to know. Your assignment for this is going to be right on Google Classroom. If you have any questions, remember to reach out, and I would love to help you. And I hope that you guys have a great day.